Welcome to the 5th tutorial on sprites in NextBASIC on the ZX Spectrum Next. This is probably the final tutorial concerning sprites. There might be some future tutorials such as tiles or incorporating music into a game, but for now I think this concludes us on sprites. So what I want to do in closing is show you how to get Kempston joystick support working from your basic games, and also how to do diagonal movement. We've been programming Pac-Man so far, so there's no diagonal movement in Pac-Man, but it is something that's featured on many arcade games, and it's not something that's really easy to do in BASIC, but it can be done, so we're going to cover that. Alright, first of all we want to call up a little sprite that has some diagonals on it, so I've created one for you. Let's take a little look here, hold on. Browser, into programs, spaceship.spr. Okay, this is what I've created. It's something like what you would see on asteroids, I suppose. You've got a little ship pointing upward by default, and there are 2 frames of animation. If I just show you, there's a little jet on the back of the ship. It goes on and off, alternating. And I've also drawn a graphic for the ship pointing up and right with the same little jet. So that's all we need to get all 8 compass directions going to facilitate normal and diagonal movement. So if you'd like to create something like that, you can follow through with this tutorial. Okay, moving swiftly on. So this time I've created a little program for you because I think it would be a waste of time to start coding this from scratch. There's nothing unfamiliar to you in this listing. It very much is the same as Pac-Man in the way it's designed. First of all, we've got a section that loads our sprite data in. Then we initialize some variables. Then we have a main loop containing some display statements and some movements. And that's really all there is to it. I'll just point out that we're using X here to control the ship. So X determines where it is horizontally, Y determines where it is vertically, so that's the center of the screen to begin with. The variable P will be used to control which particular pattern, which sprite pattern is associated with the player, and D controls which direction that pattern is facing, with that one being the default one, which is up. Alright, so in our main loop, we've got 2 sprite statements rather than 1 this time, and that's a simple way of getting the graphic to alternate. So the only difference between these 2 statements is one has P and the other one has P plus 1. So at the beginning of the game, that's going to be pattern 0, which is the ship facing up with the jet off, and pattern P plus 1, which is 1, and that's the ship facing up with the jet on. So that'll go round and round, alternating that graphic, and we should get a little flickering effect, which should be quite nice. So, movements then. Now, I'm using inky string, but inky string is not very useful because you can't hold 2 keys down at once, which is a problem if you want diagonals. For instance, if you had the traditional Q, A, O, P controls or cursor controls programmed, doesn't really matter what keys. If I wanted to go up and right at the same time, I would hold Q and P simultaneously. And that has been a feature of many games that I'm sure you've seen back in the day, but you just can't do it in BASIC. At least you can't do it using inky string. So to start with, I'm going to show you this, how you might do it the long way around if all you had to play with was inky string. So I'm using a whole bunch of keys here, and they form a circuit around the S key, starting with W for up, and then it's E for upright, D for right, C for down right, X for down, and so on, all through the 8 compass directions. And then we simply loop back around to the start of the display section, and round it goes. Now all these movement keys, they simply call subroutines that should change the X and Y values of the sprite and change the direction of the graphic. So goes for up, for instance, it goes down to 7010, and I've got it rammed out here for clarity, so that's move up. The pattern should be 0, the direction of the graphic should be the default, but we take 1 away from Y to move 1 pixel up the screen. So moving up and right, change the graphic to pattern number 2, which is the ship facing that way. It's still the same default pattern direction. We add 1 to X and we add 1 to Y so that the ship moves a tiny little bit up and right, and we return. Right is straightforward, except we add 1 to X and we change the graphics so that it rotates right 90 degrees by using bit number 1. We've covered all this in previous lessons, and we really only need those 2 different graphics. Well, it's 4 because I have 2 frames of animation, but we only need those 2 to get all 8 compass directions. We've got this way, we've got this way, and we can extract all the others just by adjusting the binary bits of the direction. So for instance, to make the ship go down and right, we want to use the graphic that by default faces that way, and we want to rotate it 90 degrees so that it goes down like this. Okay? And so on for the rest of the directions. It's all pretty easy to figure out. You just have to know which binary digit to adjust to either rotate or flip horizontal or flip vertical. As I said, all covered prior. Now, don't worry about this stuff just yet. There are rem statements in front of it. I'm going to explain this later. So let's run the game just to show you it in motion. There's my little ship, and I should be able to move it up and down and left and right, and also all of the other compass directions, and there it goes, using the typical keys. And that's very nice. Yes, like it. Okay, but it's no good. It's not very controllable with those keys. So we really do want Q, A, O, and P to work properly. But believe it or not, it's actually simpler for me to explain Kempston joystick support than it is to explain keyboard support for multiple key presses. So we're actually going to start with the Kempston joystick, and then we're going to explain keyboard after that. And it's amazingly easy to do this. It's so easy, in fact, and it's something that was a feature of 48K Basic as far as I can tell. I'm surprised I didn't see more program listings back in the day that used Kempston joystick support, but mostly anything I typed in that I remember from magazines and books, it always used INKEY string, which was such a drawback for games that really would have benefited from the ability to move diagonally. Okay, so I'm just going to create in line 8000, say, a little routine that will make it really easy to explain how joystick control works. So I'm just going to create a little joystick tester, and I can do it in just 2 lines. So on the screen, just at the top left, 0, 0, I'm going to print the contents of a hardware port. And that port is 31. So to read hardware port 31, I just use in 31, like this. And if I like, I can make it an integer, like so. But back in the day, you wouldn't have been able to do that. In ordinary 48K Basic, it would have been just like that. I want to add a space after it because I might get a single digit number or a double digit number, and I want to be able to rub out what was there before just to make this accurate. So at the top left corner of the screen, we're going to print whatever is in port 31. And I want that to cycle back around and keep doing that check. Okay? Very simple. This just goes round and round and round, constantly reading port 31 and printing it to the screen. So let's run line 8000. Okay, currently by default there is a 0 in that port. Here's my joystick plugged into the next. I'm going to move it up and we get an 8. Okay, let go, it goes back to 0. I'm going to move it right, I get a 1. Isn't that interesting? If I move it up and right at the same time, I get a 9, which is the 8 and the 1 combined. Down is 4, So you can work out what down and right would be, yeah? It would be 5. There it is. Left is 2. And the only other one to worry about is far, which is 16. It's the only double-digit one. So already, with that simple little program, we are fully reading the Kempston joystick for all 8 compass directions. So it's not going to be hard to program this into a game. It really was that simple back in the day, but rarely used. So we're going to do that now. And if you're wondering why those particular numbers, well, it'll become clear when we convert them from decimal into binary. So what I want to do is I want to go back to this section that contained all those key presses, this here, and I want to adjust those, not to use inky string, but to read the contents of that port. So I'm going to say, I'm using the variable p already, so we'll just call it port. No, I won't, because I want to use single digits, because ultimately we want to use integer variables. So j for joystick. Let j equal whatever is in port 31. And then these lines are simply converted to, if j, now this is for up first of all, can you remember what up was? Up was 8. If j equals 8, then go sub 7010. Let's just do the ordinary compass directions first. We'll forget about diagonals, so we'll do right now. If j equals 1, 1 was the right. Down was 5. No, sorry, down right was 5. Down is 4. Left is 2. And I haven't got far programmed into this, so we'll not worry about that just yet. Okay, let's run this. Whoa, variable not found, 2030. What have I done? Yes, I've got rid of p string, so I can't have that there anymore. Shouldn't have done that. Right, let's just, for the time being, leave p string in. I will be getting rid of it, but we'll just leave it there for now. Okay, there we go. So up should work, down should work, right should work, and left should work. Excellent. The diagonals won't yet work, as you can see. Just up, right, down, and left. But of course, it's easy to work out the diagonals because it's everything in between. So, diagonal for, no, that's okay, I want to leave that alone. This is my first diagonal, up and right. It's just a combination of the 8 and the 1, so it's j equals 9. Diagonal down and right, it's a combination of the 1 and the 4, 5. Diagonal down and left is a combination of the 4 and the 2, 6. And lastly, diagonal up and left is a combination of the 2 and the 8, which is 10. Now I no longer need my inky string, so I'll delete it properly this time. Right, I should have full diagonal support in Kempston joystick. Look at that. Very responsive. Like a real arcade game written in BASIC. Now, to explain why these particular values are there, I'm going to represent the 8 in binary. So 8 in binary is bin, like so. 1 in binary, and again I'm just doing the normal compass positions first, is that. 4 in binary whoops, gone too far. That's 4. And 2 in binary is 1, 2, 3, 4, 5, 6. That is that. So here's 9 in decimal. If I wanted that in binary, you can see that it's a combination of up and right. So all you have to do is represent the two binary numbers together. So this one's active, this bit is active, bit 0, and this bit, which is bit 3, is active. So, or set rather. So set bit 0, whoops, and set bit 3. So it's much clearer now why these numbers are used. You see? So these are like little flags, right? And we're only using the rightmost 5 of them. We don't use these 3. So we have, this is the flag for up, this is the flag for right, this is the flag for down, and this is the flag for left. Alright? So let's fill the rest of them in binary so we can really see this clearly. So it's a combination of that and that. This one's a combination of that and that. And lastly, that one's a combination of that and the very first one, which is that. So I hope that kind of makes it clear. It's just a case of, you know, as I said, you're either holding the direction or you're not. And it's either a 1 or a 0. Let's just make sure everything's still working, because I tend to make mistakes, as you know. But yep, it's all still working perfectly. Excellent. Now, if you had a simpler game, there's quite a lot of instructions there, but if you had a simpler game, such as something like Galaga, that you wanted to be able to move left, right, up and down, and diagonals, but you were content enough to have your ship facing up at all times. Yeah, there's a way to do that. So I'm going to show you that now. Okay, I'm going to get rid of my lines relating to diagonals. And even though I'm getting rid of them, we're going to program this in a way where diagonals will still actually work. 2070 and 2090. Okay, they're gone. So that's just the ordinary compass directions of up, down, left and right. Now, I'm going to restructure this a little bit. I'm not going to go to a subroutine. I just want to keep it simple, like this. That's going up, so let y equal y minus 1. That's going down. Sorry, that's going to the right, rather. So let x equal x plus 1. That's going down, so let y equal y plus 1. And that's going left, so it's let y equal y, sorry, let x equal x minus 1. Okay, I'm going to run that, make sure it works. Again, we've just got ordinary, yep, that's exactly what I wanted. So it's like Galaga. Could you move up and down in Galaga? I can't remember, maybe you couldn't. But you've seen games like this, vertical scroller, where you can move up, down, left and right. Or if you want to, you know, you could start with your graphic facing to the right and you could have an OR-type style game, or Chronos, depending on which your favorite horizontal scroller is. Yeah, you could have it like that. Did I say a vertical scroller? I meant horizontal scroller. So we need diagonals. Now, notice I'm not calling those subroutines from down below anymore. So I'm actually going to just ignore them. In fact, we'll just erase them entirely from the program, just to keep things simple. Okay, there we go. Movement greatly simplified. As long as you're prepared to stick to one graphic that doesn't rotate, that's a much more simplified movement routine. But we want diagonals. And I'm going to show you how you're going to do it without adding extra lines for diagonals, because all you got to do is combine this and this. Alright? So we're going to use the Bitwise AND operator that dreaded thing that I showed you in the last exercise in tutorial number 4. But it's a little simpler here. So because I'm using the bitwise AND operator, and because this is a special part of NextBASIC that wasn't there previously in Sinclair Basic, we definitely need to use integer variables for this. So I need to put the percentage symbol in front of that to make sure it's treated as an integer variable. So these are all going to have to be integer variables. There we go. Now we want to read it like this. Okay, I'll program the other 3 and then I'll explain what I'm doing. Okay, that should get me diagonal movement. I'm just hoping I didn't make a mistake. Let's test it. Yep, it's all facing the one direction, but it's lovely smooth diagonal movement with the joystick, as you can see. What megahertz am I in at the moment? Let me just check. 14. So let's see what this looks like in 28 megahertz. Absolutely flying. Of course, that'll change when you get other sprites on the screen and you start detecting for collision, but it looks really nice and it plays really nice too. So, why is this working? Well, we're using the bitwise AND operator here, if we just consider the up direction first. Instead of measuring whether up and only up is pressed, in other words, whether port 31 exactly equals this value, we're using the bitwise AND operator to say only does bit number 3 equal 1, and we're ignoring all these other bits, right? So I'll add a little rem line here to try and sort of take you through the logic, just like I did in the last one. 2021 rem. So the way it works is, let's say I am holding up. Let's say I'm holding up and right at the same time. That means the binary value in J in port 31 is going to be this. That. Okay, so that's right. You see that? And that's up. So if I'm holding upright, diagonal, that's going to be the value in port 31. So when you apply the bitwise AND operator to that, I'll just leave the word bin out because I'm not actually programming this. This is just a remark. When I apply the bitwise AND operator, and I suppose I better do this on a separate line just for clarity. There's a little AND. So the bitwise AND operator with this value, which is, okay, and notice I want this to work out to, I want this to be equal to that, which is the value for up, right? So here's what happens when you work that out. Remember, the player is holding up and right, but you want y to equal y minus 1 when that happens, right? So the answer to that is that and that is 0, 0, 0, 0. That and that is 1. That and that is 0, 0. And that, they're not both 1, so it has to be 0. So the end result of holding up and right on the joystick is this. Now that does equal that, okay? So y will equal y minus 1. So up will be pressed and 1 digit will be taken away from the vertical position of the player. Okay, so let's now do the same thing. Remember, you're still holding up and right with the joystick. Let's do the same thing to the next one, which is the controls for right. So 2041. Remember, that's the value of port 31, which is what you're holding. I might be doing overkill in the explanation for this, but I just realize how difficult it is to deal with binary and to deal with things that are more like machine code than basic. So this is why we're doing this. So this time we're ANDing whatever's in port 31 with that value, which is 1, 2, 3, 4, 5, 6, 7 and a 1. And the result we're looking for is that value, right? So when AND is applied to this, the answer is 0, 0, 0, 0, 0, 0, 0. This and this is 1, so the answer is 1. So that's the result you get from the bitwise AND on the two things. So you actually get a positive result which is equal to the thing that you're looking for. So yes, x will equal x plus 1. So when holding up and right, you will get y equals y minus 1 and x equals x plus 1, both calculated as true. Therefore you will get up and right movement on the screen. Clear as mud, as I tend to say. Yeah, it's hard to understand, but that's how it works. Right, let me get rid of this stuff. Something that I forgot to mention before when we were talking about Inky String, it's kind of handy that the fire button is actually 16, is actually bit 4. 0, 1, 2, 3, 4. That's the fire button bit there. What that means is, if you're programming a game in BASIC and you want to be able to hold any of the directions while pressing fire, not just fire on its own. If you just did if in31 equals 16, then it's only going to be true when the fire button is held and nothing else is held. In other words, you won't be able to move and fire at the same time, which is not good. But you could simply do, and I'll just type this, but I'm not going to actually run it. You simply could do if in31 is greater than or equal to 16. Then execute the fire routine. So what does that actually mean? Well, I can demonstrate what that means quite easily using our little keyboard tester routine from line 8000 here. Watch this. So when I fire, I get 16 in that port. But when I fire and move right, if I move right and fire at the same time, I get 17. If I'm moving down and I fire at the same time, I get 20. So by saying if in31 is 16 or greater, that means all of these values, which is me holding fire and moving, are all 16 or more. So it means you really can do two directions and fire at the same time. So for instance, up and right and fire, that's three things all at the same time. It's 25. But as long as you remember it's greater than 16, you can have your program very easily activate the firing routine. Alright, something to remember when you're programming. So that pretty much concludes Kempston joystick support. Now I want to do keyboard support. And it's a little trickier to explain, but it's generally in the same sort of ballpark. Now that's why I've typed this out for you. The keyboard doesn't just use one port, it uses several. It uses all of these. I think that's 7 of them, right? And there's the keyboard all mapped out, including keys like space, symbol shift, enter, and also cap shift. Now where's my cap shift? Where did I put it? Have I lost a line? I have. I've done a silly thing. as I typically do. Right. I better put it in for you. So, good job I spotted that. 65278. That's normal cap shift and ZXCV. Okay, that's more like it. That's the entire Spectrum keyboard represented. And if you're wondering where things like the full stop and the comma are and the speech marks, you have to think back to the 48K days when you didn't have those separate keys for it. Speech marks, or rather quotation marks, they are on the P key held with symbol shift. And the comma, I believe, is on N or M, because it still works. Yeah, the full stop is M. That's me holding Shift M, symbol Shift M. And that's me holding symbol Shift N. Okay. The semicolon, I think, is K. No, it's a plus. Hang on. Where's the semicolon? Is it O? Yeah, it's on the O key. So if you needed those odd keys, you just got to remember that symbol shift goes with some of the keys to produce some of the things. And the cursor pad, which we have on the Spectrum Next, and it's also there on the Spectrum Plus on the 128K, those are mapped to the keys 5, 6, 7, and 8 with shift held, just a normal shift. So let's just make, I can never remember which one is up and which one is down, but 5 is left, so 8 is right. Cap shift 8, yeah, it takes me to the right. Cap shift 5 takes me left. Cap shift 7 takes me up. Cap shift 6 takes me down. So if you want to program the cursor pad, if you remember 5, 6, 7, and 8, you can do that quite easily because you've got the numbers here associated with ports. So let's do QAOP just traditionally. So if we want to do up is the Q key right here, and that's associated with port 64520. So when we read that port, we should get Q, W, E, R, and T all accessible from that port. Now it's done in a little bit of a weird way. In the Kempston port 31, all the values are 0 in that port when nothing is being held down. But it's actually the opposite way around for the keyboard reading. When you're not pressing any keys, all of the binary bit values have a 1 in them. And when you do press the key, that 1 turns to a 0. So it's the opposite logic, and we're going to have to accommodate that in the way that we program it. So Q 64520, binary bit 0. When I want to do O for left, there's O there, not to be confused with 0. There's O, that's binary bit 1 on port 57342. Alright, so it's all the information is there. Q, A, O, and P. And space right here if you want to program fire. Alright. You will be able to find this if you want to search Google Images for a graphic of that. Just type in keyboard ports ZX Spectrum and you'll get something like this. The one that I found actually had these represented in hexadecimal, which is no good to us in BASIC. For instance, that's actually the hexadecimal value FEFE. That one is FDFE, and so on. I don't think they can be typed into Spectrum BASIC. I tried putting a $sign before it like this and then doing FEFE, but it didn't accept it, so I had to convert them to decimal and represent them here like that. So let's now convert everything to keyboard control. So these 4 lines. So the port, we don't want to read the port here because with Joystick it was simple because there was only one port to read. Now we have several ports to read, so I'm going to take away a line 2010 completely. So if in 64510, put a space there, ANDed with binary value for bit 0 equals 0. Then let y equal y minus 1. So remember in the Kempston logic we had to actually do bit 1 equals bit 1, but now it's bit 1 equals 0 because we want to check, is that bit 0 rather than is that bit 1? Opposite logic applies. Now we'll do the right hand side, pressing P to move right. Five, 7, 3, 4, 2. And it's still binary bit 0 on that port. Yep. Now we want to check down. 64022. Again, it's bit 0. And finally left. Five, 7, 3, 4, 2. And you'll notice it's the same port this time as left. Left and right are on the same port. O and P are close together on the keyboard horizontally, so this time it's actually the second binary bit known as bit 1 we need to measure equals 0. Okay, that should be keyboard control for left, right, up and down programmed. Let's test it and hope for the best. Left, right, up. Oh, up's not working and down's not working. So I have got my left. Okay, it's Galaxians. We're stuck with Galaxians. Oh, something's happening when I tap up and down, but it's not quite right. What have I done wrong? Let's just check that I'm using the right port, 64510 for up. It's actually 64520, right. My mistake. And down, which is y equals y, 64022. That's the A key. 65022. Where is my brain? Now let's try. Still not working. And that's interesting. When I held cap shift there, for some reason I've programmed the cap shift to move up. I've definitely done it wrong. What have I done? Okay. Okay, I had to stop the recording there for a moment. Yeah, I did have a mistake in my notes. This should be 64510, as I had that originally, I think. So that's Q. Q is 64510 for up. So that's up, 64510. And then A is down, and this is the one for down, which is 65022. Let me make sure I'm doing left and right correctly. This is right, which should be 57342, and again 57342. Let's run it. Yep, there we go. That's how it should operate. We got there in the end, folks. Sorry about all the mistakes. So, I hope you have fun with your own programming. Now, I suppose in concluding, I should really do one for the fire button. I haven't got a firing routine done, but it's really no problem to add something for firing. It's just a case of the space key, say. So, where is space on my table? Let's take a look on my notes here. Space is port 32766, 32766. Compare that with binary bit 0. then, okay, what'll I do? I'll change, once fire is pressed, I'll make the border change to a random color. How about that? Might be a bit crazy, but we'll just do it for fun. Border RND multiplied by 7. I wonder, do we have to do an integer before that? Maybe we just do an integer expression like this. Hopefully that'll work. And it just makes something happen on the screen when I press fire. Whoops. There we go. Run. Oh my goodness. Not what I expected. So it's just happening even when I don't do anything. Ah, I forgot my equals 0. So I did an equals 1, didn't I? No, I didn't. I need an equals 0 in there. There we go. That's it. Now, as soon as I press space, I should get a colored border. So there's the fire bit now. Does it work when I'm holding a direction? It does indeed. So I can move away and I can press space at any time with multiple key presses. Okay, that's very nice. So that pretty much covers anything you might want to do with player control using hardware sprites, or even not using hardware sprites, because, as I said, this could have been done back in the day by simply reading these hardware ports. And it's a shame it wasn't exploited more in BASIC, but there you have it. Alright folks, take care, and I'll hopefully see you sometime later with some more tutorials. But for now, I think I need a rest. Cheers!